All right, now we've come to the last topic for today. Okay, so far in the programming, you probably have seen two kinds of error messages: syntax errors, okay, and exceptions. So syntax errors, you get these things like, while true print hello and it's wrong because this thing is wrong, right? So invalid syntax, right? And then there are also other kinds of errors that you detect during execution. Those are called exceptions, right? And what you've seen is like division by zero, name error, type error, okay? Now, so zero division error is the following. Basically, if you try to divide by zero, right, and then you will have this division by zero error, okay? Name error is that if you try to call a variable, okay, and it's not defined, then you have this name error, okay? And then if you try to add a string to an integer, you have a type error, okay? So the simplest way to try to handle these kinds of exceptions is what you call the try except block. So you have a try, okay, you have some piece of code here, and then you have accept. Okay, so this accept is to essentially catch the exceptions. Okay, so here you do z equals to x divided by y, and then you do zero division error. So if there's any error here, it will be caught inside here, right? And then you will be able to do some work. Okay, so try clause is executed, right? If exception occurs inside the try clause, then you will skip to the rest, and then you try and match the accept clause. Okay, if no exception, then it goes to the end. Okay, and there's also sometimes a finally clause. The finally clause is always executed before leaving the try statement, okay, whether or not exception has occurred. Okay, so essentially this is the format. You have a try, okay, something here, right, and then you have accept some error type, okay, just do some stuff here for this error type, right, accept another error type, and this is for this error type, okay, and you can also have accept with nothing, okay, this is wildcard. It means that you will basically catch any exception that is not previously caught. Okay, and then you can also have a finally clause and an else clause. So essentially, you can try something, right? If there's an exception, you will catch. If there's this exception, you will catch and do this. Otherwise, you will do this. Okay, and whatever happens up here, right, you always do the finally clause. Now let's look at another example. So in this case, if you have this particular piece of code, and if you divide 2, 1, okay, the result is 2, 0. So essentially 2, 1 means that this is okay, no exception. You print the result is 2, 0, 2.0, and then you execute finally. Okay, you try 2, 0, okay, that means here x is 2, y is 0. You end up getting the 0 division exception. Okay, and then you do division by 0, and then you end up having the finally clause. Okay, if you do divide 2, 1, okay, this is a string with a string, okay, so this is a problem, right? That means it will not be caught here, okay, and else is for when there's no exception, right? So it didn't get this one or this one, and then it goes to finally, but exception actually runs out this clause, so then you have this type error, okay, that's not caught. Okay, now so far what I've shown you is that you put a try catch clause to catch exceptions that other people throw. It turns out that you can also throw your exceptions, and the way to throw exceptions in Python is to use raise. Okay, so if you raise a name error, it means that you are at that point in time throwing a name error exception. Okay, and this can be caught at a high level. Okay, so the built-in types are actually given here. Okay, you can go check Python 3.3. Okay, and you can define your own exceptions as well. Right, so for example, you can define your exception as a subclass of the exception class, right? Essentially, you can create user init, right, and you can embed stuff inside. Okay, and str is for printing the string representation of the exception. Okay, so you can return representation yourself. Okay, so if you do this, right, and then you raise my error 2 times 2, okay, and then accept my error as e, okay, then because over here your error has defined a value to be value, okay, you can extract out e dot value, okay, and exception value is 4, okay, because this thing goes in as a 4, right? So yep, if you try to raise my exception, oops, okay, then you will have my error, oops. Okay, so the question is, why do you use exceptions, right? Basically, in the good old days of C, many procedures just return special integers for special conditions like -1. Okay, but it's are very hard to use because you don't know what's going on half the time. Exceptions are more unnatural, easy to extend, and you can also have nested exceptions because you can have one exception get caught and then throw a different exception. Okay, if you just return some -1 or something, it's not so flexible. This comes to the end of today's lesson. All right, the key idea in memorization is that in some cases you have computations that basically repeat the same thing many times. So if you have such a computation, then what you can do is you can store the results in a table. And if the table is order one lookup, then it's very fast, okay, and you'll be able to reduce significant parts of computations. Okay, so the idea is that you basically compute a value. Okay, once it's computed, you remember in the table. And next time you call again, you check whether the value is already inside there, return the value. If not, then you compute and then you stop. MemoFit will take order n time, and the reason is because you don't compute the same thing twice. Okay, MemoChoose will take how much time? Okay, DP is actually related to memorization. Okay, when memorization, actually you kind of fill up the table dynamically. DP, you actually figure out how to fill up the table from scratch, right? And sometimes it requires more computations, right? And it also requires you to know exactly what entries you need to compute, okay? But then if you are clever about how you're doing it, right, DP can be made more efficient because you know exactly which things you need. Once you're done with them, you can throw away and reduce memory. Whereas memorization, you're just kind of doing dynamically. You don't know what memory you actually need beforehand. And basically, like Fibonacci, you can use DP to make it faster.